So this is video 2 for unit 12, which is trig transformations. We're still going to be looking at periodic phenomena, but how it pertains to sine, cosine, and tangent. So on the screen, you should already see a couple definitions. We have standard position for an angle, and then we also have a terminal ray. So if you want to pause the video or watch those, copy those down. If you need to, you can go ahead and do so. Now down here, we have an angle in standard position. And standard position is when the angle's vertex is at the origin and what did I call it up here? And one ray of the angle lies on the positive x-axis. So that will be here where the green is. Now the second definition was our terminal ray, which will be the second ray, all right? And when we open this up, that means our theta will be in here. So this will be our theta. So a ray is just a point on one end, and then the other end is going in a certain direction. So the starting point for both of these is at the origin. So this is just a recall. So recall that from previous units, we talked about positive angles. Positive angles are going to open counterclockwise or anti-clockwise. So it's going to open up in this direction. And then our negative angles, those will open clockwise. So that will open up in this direction. All right, so the next part is more specifically about sine and cosine. This is a lot of review, so you can pause and read the definitions if you want to. But essentially, we're looking at an angle in the first quadrant, and we have a point PX. So if we, sorry, not PX, we have point P and it's at coordinate XY. So just a quick reminder, this X is also going to be our cosine theta, and then this Y is going to be our sine theta. Now we're going to be exploring circles that no longer have just a radius of 1, which is why we see R here. So now the radius can be 5, 10, it could even be like 2.5 or something like that. So now when we talk about these points, X and Y, it's going to be something a little bit different as we move forward. But for now, we'll just say that this radius is 1. And we just need to recall that X is the adjacent side of our right triangle, and that's going to be adjacent to our theta. And then Y is going to be the opposite side to our triangle, which will be also to our theta from the origin. And then also your R is going to be your hypotenuse to theta. So if we scroll over to the right side, this is the definition for sine theta, which is equal to y over r, which is going to be opposite over hypotenuse. So we're thinking of SOHCAHTOA again. Cosine theta is going to be x over r, which is going to be adjacent over hypotenuse. And then tangent is going to be y over x, or sine theta, because y is sine, over cosine. And this is going to be our opposite over adjacent. So y, sine theta, and opposite are going to represent the same thing. And then x cosine theta and adjacent will represent the same thing as well. Okay. All right, so down here we have our first example. The figure to the right shows a circle with radius 5, so we're stemming away from the unit circle. Centered at the origin with an angle of measure theta in standard position, the terminal ray of the angle intersects the circle at point P. Find the following values. So we're going to be finding sine theta, cosine theta, and tan theta, which means we need to determine the values for this triangle, okay? Now we're given a point in quadrant 1, and based on this circle, we have that symmetry where if it's 0.34 in quadrant 1, then that means point P will be positive 3, negative 4. So the triangle that we are looking at is this one. Okay, since we are in quadrant 4. And this is our right triangle. So we have coordinate point 3, negative 4. And we talked about a few things meaning the same thing. So my x in this case is equal to 3, which is also going to be the adjacent side for that triangle. And then we have our y coordinate is equal to -4. That's going to be our opposite side for the triangle. Now we also need our r. Our r we were told is 5, and that's going to be our hypotenuse. So now when I'm identifying sine theta, we are still going to do opposite over hypotenuse. So thinking of SOHCAHTOA, opposite is going to be y, and then the hypotenuse is going to be r. Now in previous cases, we could rely on just using the y coordinate because our r was always equal to 1. So we never really talked about writing anything for the hypotenuse because it was just 1. We only needed to focus on the numerator. But now that the radius will not always be 1, we have to make sure that we include that in our ratios. So y is equal to -4, and then r is equal to 5. Therefore, sine theta is equal to -4/5. Now we can do the same thing for cosine. That's going to be x over r. X is equal to 3, r is equal to 5, so we have 3/5. And this makes sense because if we go back and think about this, all students take, well, all of you have to take chemistry, but I like saying all students take calculus. For sine theta, in quadrant 4, only cosine is going to be positive. So it makes sense that sine is negative. And then in quadrant 4, cosine is positive, so it makes sense that this is positive. So according to this, that means tangent should also be negative in quadrant 4, okay? So tangent theta will be y over x. Our y value is -4, and then our x value is 3, so we get -4/3. So it matches. And then just keep in mind, I do have students ask about units. We are taking a length divided by a length. So if it's, say that our triangle had a unit in inches, it's 4 inches over 5 inches, which means because we're using the same triangle for all of these, the units will cancel out. See, these are technically unitless, which means they are dimensionless. So there won't be any units when we're evaluating the ratio of 2 sides of a triangle because the lengths will cancel out, okay? So don't worry about including units or even writing the word units for this one. Example 9 looks lengthy, but once we dig into the multiple choice, it's pretty straightforward. The figure, should say to the right, shows a circle centered at the origin with an angle of measure theta in standard position. The terminal ray of the angle intersects the circle at point P. So we're talking about this one here, quadrant 1. The coordinates of P are x and y. Which of the following is true about the cosine of theta? So we have this, we're in quadrant 1, point P. I know, based on this, I know that my radius is going to be 3, okay? Because the radius around this entire circle is going to be 3. If I see the radius is here, then that means the radius will be the same here as well. Now, I'm not giving any information about point P, so I'm just going to call this x, and I'll call this y, which means point P is just technically x over y, or sorry, x comma y. So they're asking about cosine theta. Well, cosine theta is going to be x over r. We don't know anything about x, but we do know r, so we get x over 3. So now I'm going to check my multiple choice. Now, they have a description for each one, but if I just focus in on this, cosine theta equals x over 3, y over 3, y over x, 3 over x, I can see that this is the only one that truly follows SOHCAHTOA, which is CAH, which is cosine is going to be adjacent over hypotenuse, which is x over 3. Okay, so the true answer for this one is going to be A. Example 10 is going to be a little bit more demanding algebraically. So it says, let theta be an angle in standard position whose terminal ray coincides with the line y equals -3x in quadrant 2. Find the following values. Okay, so we're focused on quadrant 2, but I'm going to go ahead and draw and include quadrants 1 and 2. And it says we are looking at the line y equals -3x, so we'll use the blue for that. So this is the line y equals -3x. And we are looking for a theta, right? We want an angle. So that means we're opening up from here. And the circle is going to go all the way around, but I just want to focus on this one right now, okay? So the point that we are truly interested for this theta is right here. This is what we are looking at, okay? So that means if I want to evaluate cosine, sine, and tangent, I need to use this right triangle, right? So it'll be this pink triangle. That's what we want to look at. Whoops, terrible. Do. Okay, this pink triangle. So we need to figure out, if we're going to evaluate these, we need to have something for y, we need to have something for x, and we need to have something for r as well. So I'm going to extract my little triangle. Jeez, these are not good. All right, there we go. So I'm going to pull out the right triangle so that we can take a better look at it. There we go. Okay, so my y value, I know that y is going to be negative 3x, and y is going to be this here. And then we'll call this x. And then I'll give some space for y. So I know that y is equal to negative 3x. And then I don't know what x is equal to. Now, some people in class were like, oh, it's equal to, x is equal to negative y over 3. Okay, that is true, but we need something to do with r, all right? We have 3 variables, and right now, if we do it this way, we have 2 sides that only work with 2 variables. So we need to include r within these variables somehow, okay? So for x, I have x and y and r, okay? What I brought up in class was that we have an equation for this line. Now we need an equation for this other part that we are using that coincides with this line, which is a circle, okay? And the equation of a circle is going to be x squared plus y squared is equal to r squared. So now I finally have an equation that has all 3 variables, okay? And if I think about it, if I am able to rewrite x in a way that has r and rewrite y in a way that has r, then that means I don't need to solve for r, because all of these, sine of theta is equal to something over r. Cosine theta is equal to something over r. And then for tangent is equal to y over x, okay? So I know that y is already equal to negative 3x, so I'm going to have my x's cancel out, and we'll come back to solving this in a second. So the goal is to have no variables left. And now the r's will cancel out as long as we get an r with our x, because if x has an r, that means our y will have an r, which means we can cancel out that r, okay? So bottom line, have an equation for y, have an equation for x, okay? You don't need to do an equation for r because they will cancel out. So I know I have x squared. My y is equal to negative 3. So I'll do negative 3x squared, which is equal to r squared. So we get x squared plus properties of exponents. Negative 3 squared will be 9. X squared is going to be x squared is equal to r squared. These are like terms. They have the same variable, same power. So we can just add 1x squared plus 9x squared. So we get 10x squared is equal to r squared. So for this one, we are solving for x because we substituted in for y. So I end up with x squared is equal to r squared divided by 10. And to isolate x, I'm going to end up with plus or minus the square root of r squared over 10. So if I continue with this, I can apply the square root to the numerator and the denominator separately. So I get r over root 10. Now, remember, think about when you're taking the square root of an equation, you end up with plus or minus. But we're not going to use both of these, okay? So think about our triangle. It is in quadrant 2, and we're solving for x, okay? So that means because we're in quadrant 2, x is going to be negative. So that means we are going to use the negative value for this. So we'll have x is equal to negative r over root 10. So that's what we're going to use for our x. So now we have our two variables. We have x is equal to r over root 10, and then y is equal to negative 3x. So let's use these two and see if we can reduce these or manipulate them to a point where no variables are left. So sine theta is going to be y over r, okay? So that means my y is negative 3x, and then my r is, I'm just going to leave it for now. But now we also have something for x. We have negative r divided by root 10, so I'll have negative 3 times negative r over root 10. And this is all over r. So I have two negatives in the numerator, so those will both cancel out. So I technically have 3r divided by root 10 over r. And if I want to rewrite this without having that fraction in the numerator, I can rewrite it as 3r over, actually let me write the r first, r root 10. So essentially what I did was, if I didn't have that slanted fraction, it would look like this, okay? 3r over root 10. This is technically, we're technically multiplying 3r over root 10 with 1 over r. So it's like 3r over root 10 times 1 over r, which is how I get to here. So the last step was what I talked about before. The r's will cancel out, so we get 3 over root 10. For cosine, we're going to have x over r. My x again is going to be negative r divided by root 10 all over r. So we have an r, so usually we'll cancel stuff out when they're both in the denominator. You can also do the same when they are in the numerator. So I've been talking about these types of fractions for a while. I want to ask how many r's go into negative r root 10. The answer to that is going to be negative 1 over root 10. That's how many r's are in there. Because we have, technically we have negative 1 root 10 times r. So how many r's go into this? Negative 1 over root 10. There's also the keep, flip, change. I can't remember what it's called because I don't ever use it. But I always just think, okay, how much of the denominator is going into the numerator? So whatever works for you. If you need the keep, if you need the flippity, changey, that's fine too. Or they both have an r in the numerator, so they will both cancel out. The last one is going to be tangent, which is y over x. So y is equal to negative x, and then we have x. Well, luckily we don't have to go further with x using the r because the x's cancel out, so we get negative 3. So this one's a little more extensive, but it's all about solving for a variable for x and one for y, and then the r's will cancel out naturally. All right, the above figure shows a circle with radius r centered at the origin with an angle measure of theta in standard position. The terminal ray of these angles intersects the circle at point P. The coordinates of P are x, y. The points Q, R, S are the results of reflecting P across the y-axis, the origin, and the x-axis. So we have this point P, and then when we reflect over the y-axis, which is over here, we get point Q. And then when we reflect that same point about the origin, here, we get point R. And then when we reflect it over the x-axis, we get point S, okay, respectively. So point Q, they're asking about point Q. Because it's reflected over the y-axis, our x values are now negative, so we have negative x, but the y value will still be the same. So this will be negative x, y. Point R is going to reflect about the origin, which means now both coordinates will be negative or negated. So negative x, negative y. And then reflected about the x-axis, that means our y values will be negated. So we end up with x, negative y. So example 12 says find the sine of the angle whose terminal ray intersects the circle at point S. Okay, so at point S, we're working in quadrant 4. So we want the sine of that angle. Okay, so sine, we'll call it alpha. Sine of alpha is equal to, and alpha is, we're going to be working with this triangle here in quadrant 4 for S. Okay, so there's our angle at the origin. So SOHCAHTOA, we're going to be using opposite over adjacent. Sorry, that was not right. Opposite over hypotenuse. So my opposite is negative y, and then my hypotenuse is going to be r. They don't tell us, well, we don't tell you what r is, so we're just going to keep it as r. Okay, so that means we have negative y divided by r. The next one is find the cosine of the angle whose terminal ray intersects the circle at point Q. Point Q is in quadrant 2. And if we think about this again, in quadrant 2, sine is the only one that's positive, so I should have a ratio that's negative, which is nice because I see this x here. So cosine is going to be adjacent over hypotenuse, and let's call this one beta. So now that we're in quadrant 2, we are going to be using this triangle. And then beta is going to be at the origin. So this one will be cosine beta is equal to, our x value is negative because we're in quadrant 2, and then your radius will always be positive. The last one is going to be find the tangent of the angle whose terminal ray intersects the circle at point R. So now we're in quadrant 3, and we are looking at this, let's call it omega. And based on this, that means our tangent should be positive in quadrant 3. So it will be tangent of omega is equal to, we'll do negative y over negative x, which just gives us positive y over positive x. And alpha, beta, and omega, they're just Greek letters. I didn't want to use theta again because that's what we used in quadrant 1, so I didn't want to get confused. So, all right, coordinates of a point on the circle centered at the origin. So for this one, we're going to talk about a couple more things, specifically the point for the circle that no longer has a radius of 1. So if we think about this point here, I'm going to have my triangle. We're in quadrant 1, and it's a right triangle. So this side we can still call it cosine, or it's your x value. Okay, if it was 1, we could do that. So I want to be careful with how I say this, okay? This will still be point x, y, okay? So if I think about cosine theta, cosine SOHCAHTOA, cosine is going to be adjacent over hypotenuse, which is going to be x over r. Now, if I were to rewrite this, so I could isolate x, I now have x is equal to r cosine theta. We've been doing this, but since r is always equal to 1 with our unit circle, we don't note it. We don't notate it, okay? But now that we are going to be working with circles where the radius will not always be 1, we now need to remember that that r will be multiplied with our cosine theta. And the same thing can be said for sine theta. SOHCAHTOA, opposite over hypotenuse, so we'll have y over r. If we multiply r to both sides, we can see that y is equal to r sine theta, which is where we get this from, okay? So there are three equations that you should remember, right? The first one is the equation for a circle. X squared plus y squared equals r squared. And then the second one is going to be x is equal to r cosine theta. And then the third one is going to be y is equal to r sine theta. So example 15 says the figure above shows a circle of radius 4 along the equilateral triangle PQO. Which of the following gives the coordinates of point Q? All right, so point Q, we're going to be in quadrant 2. Point P is in quadrant 1, and then O is going to be on the origin. And it looks like we have a radius of 4, okay? So there's a lot of assumptions being made here. It's an equilateral triangle, which means all of the angles have to be 60 degrees. Okay, so I'm going to do a 60 here, 60 degrees here, and then 60 degrees here. Now, the y-axis looks like it is slicing this angle in half, which means this could be a 30-degree angle here, and then a 30-degree angle over here as well. Now, I can make that assumption because if I go down here, I know that I'm working in quadrant 2. Pi over 3 is in quadrant 1. 5 pi over 6, that's quadrant 2. 2 pi over 3, 2 pi over 3, quadrant 2, quadrant 2. Okay? So based on this, I can already see that my theta is not going to be pi over 3 because I'm working with Q. Okay? And based on the position that we have of this equilateral triangle, 5 pi over 6 is over here, okay? So I know that not everything is drawn to scale, but that big of an error, that would be an issue, all right? But let's go ahead and try a couple other things. So I know that we're dealing with point Q. So point Q, my coordinate point will be xy, and based on what we talked about above, that is going to be r cosine theta and r sine theta. We know that the radius is going to be 4. So for both of these, I can at least do r cosine of some angle and then r sine of some angle. Now that angle, if I look at this, I have 90 degrees and then I have plus 30. So 90 plus 30 will be 120 degrees, which is also going to be 2 pi over 3 because we are in radians, okay? So that means I'll have 4 cosine 2 pi over 3 and 4 sine of 2 pi over 3. So if I look down here, that will be C. And also with this equilateral triangle, because this is 60, that means we can assume that this is also 60 and that this is also 60. So all the 60s. It would have helped to say if the equilateral triangle had symmetry about the y-axis. That way we didn't have to assume, but they didn't, so. But I can use the choices down below to help make that assumption. All right, example 16, the figure above shows a circle of radius r along with the line of y equals negative x. The circle and the line y equals negative x intersect at the point r, o, and p. If the coordinates of p are 6 root 2, and negative 6 root 2, what is the value of r? Okay. All right, so there are a couple ways to solve this. We're looking at point, which point are we looking at? If the coordinates of point P. Okay, so we're looking at point P and we want to solve for r. What is the value of r? Okay. So we have these formulas. You can technically use any formula. You could use y equals r sine theta. You could use x equals r sine theta. Whoa, x equals r cosine theta, sorry. Or you can use x squared plus y squared equals r squared. So let's try sine. So if I do y is equal to sine or r sine theta, my y value is going to be negative 6 root 2. So I get negative 6 root 2. And then I have equals r sine theta. Now, they told me that this line is y equals negative x, which means it's going to be splitting quadrants 2 and quadrant 4 in half. So that means down here, I'm looking at 7 pi over 4. That's my theta, all right? You can technically also use r if you wanted to, but that would change your y value, which would then be positive, and it would change your theta, okay? But we should end up with the same answer. So we'll do 7 pi over 4. Now we're solving for r, so I have negative 6 root 2 is equal to r times sine of 7 pi over 4 is negative root 2 over 2. Okay. Now from here, I can multiply the opposite side with the reciprocal of negative root 2 over 2. So I get negative 6 root 2 times negative 2 over root 2, which equals r. The root 2's cancel out, the negatives cancel out, so I get 12 is equal to r. So that's one way. Another way is we can use x squared plus y squared is equal to r squared. So x is going to be 6 root 2 squared. Y is going to be negative 6 root 2 squared, which is equal to r squared. Now think of your monomials and properties of exponents. The 6 is squared, and the root 2 is squared. Same with this one. So 6 squared is going to be 36. Root 2 squared is going to be 2. Negative 36 squared is 36. And then root 2 squared is 2. And then we get r squared. So we have 72 plus 72, which equals r squared. 72 plus 72, we get 144, which is equal to r squared. We're going to square both sides, so we get plus or minus 12 is equal to r. However, your radius is always positive. Your radius is, it's terrible, is always positive. Therefore, r equals 12. So multiple ways to approach these. There's no one way that you need to do, but just pick a way that's comfortable for you and practice that constantly. All right, hope this helps.